Okay. So here we go. A little bit of, this is the only other section we're doing from chapter 1. And I'm just going to show you how to solve an equation. In other words, what you're doing is finding the roots or the zeros. We have an equation using the graphing calculator. In general, in the book, they call it a graphing utility because they're not going to advertise any particular calculator. But using the graphing utility. And it's a little different for other graphing calculators. So definition here, complete graph. What is a complete graph? It shows all peaks, valleys, and x-intercepts. So it shows the maxes, the mins. We call it some of them relative maxes and relative mins. Because they might not be the very highest or very lowest points, but it shows what we call relative maxes and relative mins. And then the x-intercepts. And we're going to focus today on just using the calculator to find the x-intercept. So here's the process we go through. Step 1. Set the equation equal to 0. You've done that before when you've used the quadratic formula or solving by fact. Right? Set the equation equal to 0. Second step is graph it on your graphing calculator. Graph y equals f of x. That's in the y equals menu. I have the step process on there. So you go to graph. After you've entered in the y equals menu. We're going to do that in a minute here. And then you're going to find the x-intercepts using what's called the zeros function. It's under second calculate. So you'll see on there, second calculate pulls up a menu of 5 different things. And it's, I think, number 2 on there, finding the zeros. Now, this isn't the only way to do this. If we have time, or as we go through the course, I'll demo other ways, but this is the most basic way of finding the solutions or roots or x-intercepts of a function, okay? So number 1, solve graphically. This is a quartic equation, so we're actually going to learn a method for called rational roots to be able to find solutions by possibly factoring it or using long division. But at this point, we're just going to type that into our calculator. So I'm going to go ahead and do that right now. Type it into my calculator under y equals menu. Go hit the y equals menu. Clear. I think I'm going to do it from over here at the computer. It'll be a little more efficient. And I can have the equation sitting right in front of me. So go ahead and type that in, number 1, x to the 4th. You type in, on the graphing calculator, it's the xt theta n button. To the 4th power, I use this little key underneath clear. So if you see the key underneath clear here, so x to the 4th power. Now, guys, if you have the TI-83 that you checked out for me, one of the older versions, it's not TI-84, if you're not in math type, it will have the little caret key showing up, okay? It won't do math type. So x to the 4th minus 2x squared minus 3x minus 2, and you just type that in just as you see it there. Next step then is to go ahead and graph it. So go ahead and graph it. And man, in some cases, you can be pretty certain of what the x-intercepts are. Can you tell here? Yeah, but, okay, it looks like it's -1 and 2, okay, but I'm going to show you how to use the second calculated function, because what if it was -1.01, right, or 2.001 or something like that. But you could also, another tactic, guys, would be, okay, look at the graph and then just mentally plug it into the equation, see if you get zeros. So then you would know, is it really an integer? But you go to second, and then you see the trace button up here on the top. Second, and then hit the trace button. That's the calculate menu. There are actually 7 things on here. And we're going to use number 2, the 0. So if you go hit number 2 or scroll down. So here's how this works. you've got to tell the calculator what the left bound is of the 0 that you want. So if I want this 0 at -1, I need to set a left bound to the left of -1. The reason that will ask for left bound and right bound in a guess is so that it knows which intercept or root you want. Okay? So I'm going to hit the left arrow here and go a little bit left. See how my cursor is now above that x-intercept at -1? And so that's a good left bound. Anywhere to the left of that is going to work. I'm going to hit enter, and then it's going to ask for a right bound. So I'm going to hit the right arrow and keep going all the way until I am below that x-intercept at -1, and then tell the calculator that's a good spot for the right bound. Then what I do for a guess is after I've selected the left and right bound, just do whatever arrow, left or right, you need to do to get back into that region. You don't want to be on the boundary of the region. You want to be in the region. So one left arrow click will be enough. It's asking for a guess. If you want to, you can go put the cursor as close to that intercept as you possibly can, but it's not necessary. You just need to be inside of the region that you just identified, okay? So if I go ahead and just click one time to the left of my right bound and then hit enter, it will tell me that that 0 is x equals -1. Do you see that on the bottom there? So x equals -1. Okay, before we go on, I want to see. So here, you should have gotten 3 solutions on number 3. What you'll notice, guys, is if the roots are really close together, you have to be really careful about how you do your left bound and right bound. Because if for some reason that region that you select between your left and right bound has more than one x-intercept in it, you will get a domain error. It will not be able to calculate it. The algorithm or formula that it's using to calculate that will get confused if you have more than one intercept in the region. So that was my whole purpose for number 3 here, was that yes, there are 3 of them. Visually you can see them, but you can't just read them off the graph. You have to use the 0 function to get them. And you have to be careful about how you do your left and right bound. As a matter of fact, this calculator, it can only set boundaries so small. We're going to see that in the one that says technological quirk, which we might not get to till next time. There are problems with the calculator. It's limited on what it can do. It'll get confused on certain things. So that's where you have to know the math behind it. Okay? And I'll give you examples of what I mean on that. But for the first 3, I'm going to do number 4 with you. Anybody need help on the... Let's do number 4 here. I'm going to pull up the graphic calculator and enter that function in. So we'll do that together. All right, so we have, I'm assuming you're able to solve it for 0. I'm going to type in what we should get when we solve for 0. So math, num, absolute value. On my calculator, it's math type, so if you have the older calculators, just make sure you finish the parentheses when you're done with that expression that should be an absolute value. So I have x squared minus 4x, and then minus 3. And then if you have the math type, you have the right arrow to exit out of there. If you have the older version, the classic mode we call that, you just have to finish your parentheses. So it knows that that's everything in absolute value. And then I have, if I move the x cubed over, it'll be minus x. And then I use the little caret key below clear here to tell it to cube it. And then if you're a math type, you have to right arrow to get back down so that it doesn't keep typing everything after that in the power. And then I have plus x, and then, no, not plus x, what's it going to be? Minus x. Watch your signs. When I move it over, it's minus x, and then plus 6. So I've moved everything over. So you have to be very careful with your signs on this. So let's graph it and make sure we all have the same graph. If we don't, then we missed the signs. You guys have the same graph as me? With just one, it looks like there's only one x-intercept, as best we can tell.
Yes.
Okay, if you have that graph, go ahead and find out what that intercept is.